Okay, I'll quickly do this. You have your, oh boy, whatever. You get your picture. You got, let's say, one here and one here. And you got, whatever. Then your function goes like, this. Now this time you're drawing your rectangles according to the left endpoint. So for this subinterval here, I'm going like this. And then for this subinterval here, I go like this. And for this guy here, I go like this. And then the last, sorry, this subinterval down the bottom left, your rectangle is just flat. There's no rectangle really. Is there a rectangle? It's a philosophical debate that we will not have. Thank you very much. Okay, approximation. In this case, is equal to 0.25 again, times. Now it's f of 0 plus f of 0.25 plus f of 0.5 plus f of 0.75. So we have those four rectangle heights, and they have a common rectangle width. So what is this? This is a quarter. Then f of 0 is just 0, right? Remember, f is my squaring function, so when I square a quarter, I get 16, 1 over 16. I apologize for switching back and forth from decimal to fraction so much. What did I say here? 9 over 16. Yeah. Equals a quarter. 1 plus 4 plus 9. 1 plus 4 plus 9 is 14 over 16, which is 7 over 32. And if I'm not mistaken, that is correct. Yes, there we go. Okay, so we use left endpoints here. And we're going to call this L4. L for left endpoints, and then 4 because we had 4 rectangles in our approximation. That's L4. So this approximation here is called L4. And what I did in the example is called R4. So 15 over 32 is R4. So we got L4 and R4. Now, neither of those are very good approximations. One of them is too low, one of them is too high. But here's the idea. Focus on this diagram here. And think about what happens when I take more and more rectangles. So 8 rectangles, then 16 rectangles, then 32 rectangles. Now, I hope you agree that the approximation is going to get better and better and better. So we'll write this down as an idea. R8, R16, R32, R64. These are better and better approximations of the exact area under f of x equals x squared from 0 to 1. Okay, so to see that, you have to visualize, maybe go all the way up to the first one. This is maybe a better place to look. So here's 4 rectangles. If I have 8 rectangles, I'm going to have a lot less of this error. This is error, this extra white area is error, right? I'm going to have a lot less of that if I have 8 rectangles instead of 4. And if I have 16 or 100 or 1,000 rectangles, I'm going to get an even better approximation. So what does this remind us of? It reminds us of a limit as something goes to infinity. So we'll write that down. Limits as n goes to infinity of our n equals, well, we're going to take this as our definition of the exact area. That should be a star.